Hello, welcome to Revelator John. Why is icing hazardous to aircraft in flight? Well, there are various types of icing, and it could affect what was known as the lifting surfaces or the non-lifting surfaces. So if we consider the non-lifting surfaces first, in other words, the fuselage, for example, and the antenna, the landing gear, whatever it is. So we have ice build up on those, then we are effectively increasing the weight of the aircraft. So that can affect the amount of power required to maintain a particular flight configuration, whether it's straight and level flight, whether we're climbing, descending, so on and so forth. But also increased ice on the fuselage will also affect its aerodynamic properties. So whilst it's not a lifting surface itself, the object of the game here is to design a fuselage that minimises the drag, or what was known as the parasite drag over the fuselage. So anything that is sticking out in the aircraft, if we're actually increasing its size, then we're creating a greater obstruction to the airflow. And what we want over any surface, any lifting surface or any surface that has to move through the air, then we want it to minimize any disruption of airflow over it, therefore minimizes any turbulence over it. Any turbulence over it will increase the drag over it. So that's the icing over the non-lifting part of an aircraft, the fuselage, for example. The lifting parts, for example, the rotor blades in the case of a helicopter, the wing of an aeroplane, any horizontal stabilizers, any elevators. Again, so any ice that builds up over those surfaces, over the leading edge, the forward edge of the wings or the rotor blades, will affect the that stream, that smooth airflow flowing over the blades or the wing itself. So that will create more turbulence, therefore more drag. So we can have rime icing, which will have ice being formed in flying through 0 degrees temperatures in small water droplets. And you can have clear icing, which is large water droplets freezing on the wing itself, which will create larger pieces or larger secretion of accumulation, I should say, of ice on the lifting surface itself. That increased icing, that clear icing, because of the volume and the size of it, can also break off, and then that can create differences in not only weight, it can also affect differences in drag, and also lead to damage of the fuselage or the wing itself. So those are the two main types of icing: rime icing, which is a smaller icing which reflects the airflow; clear icing, which can cover the whole wing itself, but also will affect the weight primarily, and also may affect the changes in drag or changes in lift over that wing, especially if any ice starts to break off. The worst case scenario is where we have a mixture of both rime icing and clear icing. So whether the clear icing starts first, and then we have reduced icing build up on the leading edge. So you have the worst case scenario where you have disruption of airflow, but you also have a change in weight, change in drag, so on and so forth. So we will most notably witness that an increased demand of power flying in these visible moisture and in icing conditions and freezing temperatures, increased amount of power required to maintain a certain flight configuration, or may not be able to maintain level flight and will start to descend with a given amount of power. So the idea here is to eliminate the causes through flying towards the sun, in effect, getting out of the visible moisture, getting out of the freezing temperatures, but avoid these flight parameters, if you will, at all costs. Many aircraft have, especially aircraft, will have anti-icing capability. Will have heating along the blades to prevent ice accumulation. Prior to flight, they will have de-icing chemical application to de-ice the aircraft and prevent a certain amount of icing as well. Helicopters, a lot less applied. However, there are certain helicopter types that can have heated blades and also have various other designs to prevent the ice accumulation. But much more common in fixed-wing aircraft, larger fixed-wing aircraft in the airlines as well. So this is why icing is a particular hazard to aviation, to aircraft, because it can affect the weight of the aircraft, can affect the overall drag profile and the aerodynamic drag of the lifting surfaces as well, which can lead to a greater demand of power that is required. And ultimately, if that power cannot be met, then we'll have a downward trajectory, and then it can lead to an accident, an aircraft crash, and the aircraft can become uncontrollable. Thank you.